So, let's see. We have about, we have this lecture, then we have the next 2 weeks of lecture. So then we have the next 2 days of lecture on the 23rd and the 25th. And then we have the 30th. The 30th is definitely going to be dedicated to exam review, right? Please note the date, the time and date of your final exam. I think it's the 8th, right? I think it's the 8th. You might want to check. I know the date of the final exam the same way the rest of you know the date of your final exam by looking at the calendar they provide. Yours is going to be a con final. Your final exam will probably have a Scantron attached to it, just so that with a lot of multiple choice. It's like those are a bulk of the questions, so you're going to be tested on a lot of reading questions, just simply because that's easier for us to grade. But you're also going to be expected to do writing portion of it. So, and typically, you'll take the exam on that Tuesday, and I can typically get the final exam grade back to you on Friday, and then get your final grade to you. Please make sure to demo your labs, before your final exam. Also, I need to note that after the 8th, right, you might be able to catch me on the 9th when I'm doing a bit of bulk grading, but after the 9th, I'm going to be very hard to reach in person, but that doesn't mean you can't email me or meet me via WebEx to discuss any, remaining matters. Everybody kind of treats the last couple weeks a bit differently. Dr. Fiore, for instance, likes to focus on recursion, and I think I'll do that on Monday or maybe today if I have more time. I like to focus on kind of a interesting skill to expand on some stuff that I was light on earlier, specifically the try-catch block, because this is a really good place to address it. What I'm going to go over is crawling, which is not getting on your hands and knees and moving around, but actually crawling the web. In other words, how do I read stuff from the internet? Because that's where all this interesting stuff is, right? Your last assignment is going to focus, so you'll have the game of life, and then you'll have one last assignment, which is my XKCD parser. So the XKCD, if you're not familiar, is a webcomic. I happen to be very fond of it. And it's nice minimalistic web comic. They have a nice minimalistic page, which makes it a very good learning example for crawling. And your final assignment for my class will be to write a program that will download the first 100 comics of XKCD. I'm not going to tell you to do all the current comics, because that's actually a bit trickier, because the author of this comic is a bit of a trickster. For instance, right, you can go to comic 403 and that's perfectly fine, but going to comic 404 gives you a 404 error, right? Because there is no comic 404. So that's kind of the stuff that goes on here. But otherwise, it's fairly straightforward. Now, that gives us the question of how do we download. And when I say download comics, I'm not talking about downloading the web page. I'm talking about grabbing this image, which is located at images.xkcd.com /comics/barrelcrop.jpg, which also goes into how do we find stuff on the internet in general, right? Some stuff that you've kind of just intuitively used, right? Right. You may have, if you were anything like me, you may have had a teacher in middle school or elementary school that droned on and said, okay, to navigate to Wikipedia, you need to type in http:// right? And basically he told you have to memorize that, right? At least I did back in then you have to go www. But these days, if we want to do something like go to weather.com, we just type in weather.com, ignore the whole http/. And besides, you shouldn't be using http anyway. You should be using https because that means you're using SSL, a secure socket layer to communicate, so that you can keep your communication somewhat private between your site and that site, right? So there's a couple things going on with that. But, all right, so what is this up here? You probably know it as a URL. What does URL stand for? Anybody? You don't know? Well, we can always go to Wikipedia and find out. They probably know. URL, Uniform Resource Locator, colloquially known as a web address. It's a specific type of Uniform Resource Identifier, but many people use it interchangeably. And essentially, it's split up into two parts. You've got your host name, in other words, what's the website. It's a .org website called Wikipedia, and it has the subdomain of EN for English. And then it's got a file, right? And the file is located on their server under the wiki folder and in the /URL, and we're displaying the /URL file, specifically .html. Nope, doesn't do that on that one. It literally looks for an article called that. And so anyway, what gets displayed to you in web files is HTML, right? The hypertext markup language. This is not something about teaching you how to do HTML. That's kind of boring, and you can learn about it on your own. And I'm definitely not the best source for it anyway. But view page source. This is what your computer sees, what your web browser gets when you request a web page. And a lot of it's a bunch of JavaScript and a bunch of links and stuff. But eventually we get into stuff that we understand, right? A web browser will usually, a web, sorry. So let's see, so we've got there. The domain in the IRI is known as the domain name. Software will automatically convert right? So you can see that there's English in here. An identifiable language in here. And if it's a text file, that means we can parse it if we need to extract useful information from it. Now, what your web browser does is it parses this, and then it takes these things as instructions on how to display the web page. That's how this works, right? And your web browser might be able to do this better than other web browsers. For instance, let me boot up a Ubuntu shell, right? So do I have links installed on this browser? No, I do not. Sudo apt install links. So links is a text-only web browser. So let's see. It says it was interrupted. Ugh. Okay, so not really sure about that. Why it said you must manually rerun sudo dp catch dot configure a. There we go. Oh, it was saying that basically I must have interrupted an installation at some point. So it's handling that now, so I'll let it do its thing right now. But anyway, depending on how you display a web page, your web page might be able to display this, or it might display something else entirely, depending on its capabilities. Most modern web browsers are able to do stuff just fine. Us, on the other hand, if we're parsing web pages, we don't parse this. We parse the actual, data that we download. So that kind of begs the question of how do we read from a web page, right? How do we get data from a web page? Well, the good news is you already know how. And the answer is scanner. We're going to use scanner if we can use scanner to read a file, why can't we use it to read a URL, which in itself basically directs you to where a file is. So that makes sense. So we'll do that. All right. So I might refer to another previous iteration of this, but scanner is equal to new scanner java.youtube. So normally when we read stuff from scanner, we do it from system.in, right? And then to do it from a file, we would do it from file f. So here we're going to be reading from a URL, right? So the question is, if we're reading from a URL, what should we use? Well, saying that using the URL class is probably a smart guess. You can import it from java.net.url. So URL target is equal to new URL. So what website do we want to read the HTML for? Let's go with https://www.google.com, right? And then we're going to read, okay, and now it's giving me an error. Malformed, unhandled exception, malformed URL exception. And I like waiting until this. It says I can do two things. We can solve this the way a lot of you have been solving it now. We can add an exception to the method signature, saying that this program could possibly crash, right? And it will throw a malformed URL exception if this program, we're warning the user essentially this is the risk of running your program. Or we could try and handle the exception. So to try and handle exception, you can use something called the try catch block, which I briefly mentioned earlier. But now it's a good time. So try catch blocks look kind of take the same structure of like an if else, only they act kind of differently. So you've got to try, and they look like this. Essentially, any code that could possibly break, you throw into the try block, and any code that relies on that code that could possibly break, you throw in the try block. Now, generally, you want to minimize the amount of code that you put in a try block. So we try to set up the target so we can read for it. But there's the potential that creates an exception, specifically a malformed URL exception. Okay? All right. And then, so I'll leave that right there, and then I'll go into it. Target dot. And then to read from a URL, we have to use OpenStream because it won't just work with the URL. We have to actually open a connection to we have to say that we want to read from it. And now we're getting an exception saying unhandled exception, java.io exception. So let's go ahead and see how we can do that. Add another catch clause. Okay, so we'll do that. So let's go ahead and see how this works, and system.out.println. Right now, I'm not even going to try reading from them yet. I'm just going to say whether we're able to set up our scanner to read from that website. If we could, I'll print out success. If not, well, let's see what happens. So I run it, and it says success. So this code in the try catch block, it's fine, right? Because Google is a thing that exists, and this is how you open a connection to that website. Okay? But say I didn't do this right. I said, let's connect to TTPS or TPS google.com. Right? I run this. This should obviously crash. Well, it says it finished with but it didn't crash. Notice it also didn't print out success. Now, that's because of what happens in the try catch block. So let me go ahead and do a new system, a new println statement. System.er.println. Okay. You'll see in this. Give me 1 second, and I will tell you. You know how sometimes when you get an error, your text editor prints out in red, right? That's because it's not using system.out.println to talk to you. It's using system.er.println to talk to you. So when something goes wrong, you can use system.er.println to print out an error message to the user. See? So notice that I tried to connect to tps://google.com, and that's not a good URL, right? So malformed URL exception. and I printed out, oops, bad URL. So the way a try-catch block works, right, is that you have a try block, and then you can follow it with more than one or more catches. And basically, if something goes wrong in your try block, if you get an error in a try block, your program immediately stops from trying to run the try block, right? Notice that it tried to create this URL target. Right, we went into the try block, so I'll actually do that. Sout in try. So now I'll run it. It says it's in try, and then it went, oops, bad URL. That's because we tried to connect to a website that doesn't exist, tps//www.google.com. Scanner said couldn't open and as soon as it said you can't, that's a bad URL, we went to an exception and caught, hey, that's a malformed URL. And it printed out, oops, bad URL. So essentially, as soon as you get an error in a try block, you immediately go to the matching catch block, the first matching catch block. Now let's go ahead and say that it is a validly formed one, but maybe it goes to a different website that, let's see, I mean, it's hard to find a website that doesn't exist, right? Maybe let's see, does google.com exist with missing the E? So now, that website doesn't exist. So I connect to the target URL correctly, but now it says couldn't, right? I try to open a connection to that website, but I can't read from that website because it doesn't really exist. So I get a couldn't. I get an IO exception E. Now notice that these are both different types of exceptions. Exceptions in Java are objects too, right? Exceptions are objects in Java. Specifically, that means that they use inheritance. A malformed URL exception is a type of exception, which means that it is descended from the exception superclass. So all exceptions operate in the same way. And as a result, typically, most of the time when you see an exception, try catch block, most people just do one catch block, one big catch block, which isn't necessarily good practice, but at least in intro classes, we just do this. Exception E, right? If something goes wrong, we have one catch block that handles that all. And then we can do interesting things with our exception. We can print the stack trace, which is that we can print out that error that we normally get. So run it. In try, it says in try, oops bad URL, not oops bad URL, but then it printed out all this stuff that we normally identify with an error. But what's going on here is that we told it to print it out this stuff. And now here's the great thing about the catch block. It doesn't crash your program once you're done running the crash block. Sorry, the catch block. System.out.println done with program. A catch block will keep your program from ending, right? It prints out this error. It handles the error. It just says, oops, there was a bad URL. I'm going to print out what the error was, and I'm now going to say I'm done with the program. That makes sense to everybody? So essentially, if an error occurs in a try block, we immediately teleport to the catch block and then do whatever the catch block says to do. Now, you can nest these try and catch blocks, but that's not a good idea. Okay. So now let's go back to reading. Obviously, I want to read from the website google.com. So I'm in the try. I successfully connected to google.com, and that's a success. So now, how do I read from the HTML from this website? Well, I read it just like everything else. I read it just like I would a file. While scanner has another line of HTML to read, I'm going to print out that line. Print out scanner dot next line. Right, so we're really just using a lot of stuff that you already know. So here's the web page for google.com. It's very short. I mean, we can go to google.com and actually see for ourselves that it is a very short web page. Or maybe it identified that we're coming in from basically a Java connection, and it's saying, hey, yep. And a lot of this is just like a lot of code that's going on the Google web page. Gibberish to us. But anyway, it read what google.com told it to read. And oh, yeah, see? It's very long. There's a lot of stuff there. So we read what it told us to read, and now we're done reading that. Now let's go ahead and read Wikipedia page. Let's go with, let's see if it works with just doing www. Or maybe if we just do n.wikipedia.org/wiki/URL. That was the URL for our website. It says that basically that's not a good URL. We actually have to include http:// actually HTTPS. Now let's run that. In try, and it printed the entire URL that we got from, it printed out all the HTML that we got from our webpage. And now that we've got this, we can do interesting things to this. We can ask ourselves interesting questions, like in the URL webpage, how many links are there in the URL webpage? In other words, how many of these things can I click on and take me to another webpage? Right? Because that's something that's coded into the markup language. Specifically, let's go ahead and zoom in on this. Anytime you see this href, that's a link. Anytime we see a href, we know that's part of a link, right? Or if we see an li, this symbol, we know that's a link, so we can catch it. So if we count either the number of hrefs or the number of li's, that should tell us basically how many links, like over here and over here, are being displayed on this web page. So that's not like that's actually not too hard to do, but it's not like the most intuitive. You wouldn't have thought about how to do that 15 minutes ago until you realized you could have read from a web page. So let's go ahead and count that. Int num links is equal to 0. And this is just an example of one thing you could do. This is not something you'll want to include in your program. If you include this in your XKCD downloader program, this whole counting the number of links, we will strongly glare at you because you have not been paying attention and you will have just madly copied and pasted my code in a hope that it will work. You get part of this is all there's a phrase called voodoo coding, which is essentially we just include everything in our code. We don't know what it does, so because this is just magic words. We don't do that here. You got to understand what you're using. So here I just want to count the number of links in this. So and that means that I'll actually have to parse each of these lines that I'm reading. So for int, so now basically string line is equal to scanner.next line. So the first thing I have to do is say will more than one link occur in a, so it's not just LIs that I can count. I have to count the number of hrefs in here. And the question is, yes, more than one href can occur in a single line. Like here in line 104, we can get an href over there, and then we've got an href over there, an href over here, and an href over there. So it's not enough that I can just scan through and do that. So I can't scan through, do line by line, and go use the .contains method to find out if it has an href. So instead, I'm going to have to split it up word by word and look at it. So I'm going to keep this as simple as possible. So I've got a line of code. So I've got a line of HTML. So what I can do is I can split it up into its component parts. String, let's call it words for lack of better words, is equal to line. And let's see. if they're following this correctly, everything is separated by a space, right? So we'll have anything that that begins with an href will begin with the space first. So we can split it up. So we can use something called string.split. What does string.split do? It's, yes, obviously splits the string, right? What it does, it takes it up and splits it into an array of strings. So let's go ahead and just let me just go ahead up here and give an example. If I've got string s is equal to, so let me comment that out. So string s is equal to hello world, how are you? S.split, sorry, actually s out arrays dot toString s.split. Now it takes in something called a regex, which I'll just leave as a spacer right now. That stands for regular expression. I don't know if we have a course here that teaches about regular expressions. I don't. In 2168, I strongly push you to learn it on your own because it is something that I feel like you should learn on your own. It is something that takes you about 2 hours to get the hang of. It will be the most useful 2 hours of independent study that you will probably have this year if you study regular expressions. They are pretty awesome. Regular expression or regex, they basically, they're an advanced find function. You can find very powerful things in them. For instance, this is a regex over here that matches basically a bunch of spaces after, let's see, a bunch of spaces after a period. So you can do very powerful effects with regular expressions. Here we're just looking for, we're looking for a single space, and we're going to split it up on a single space. So the end result is that if we print this out, and this is useful if you've got something that you need to split up space by space. I'm just going to comment out the, actually don't need to comment this out yet. Comment this out. Our output from splitting that string up is it's hello world, comma, comma, how are you? Right? Now remember, commas separate each of the variables. So index 0 is hello, that's the first word in there. The second one is world with a comma, right? Because remember, world had a comma attached to it. And then the third index was how, and then are, and then you. So it removes essentially all the spaces from there. So we can use that. So we can do line dot split on the spaces to split up into a bunch of words. And then we'll need to do for each string word in words, for each of the words in our array, if word dot starts with href numlinks plus plus. And then when we're done with this, we can print out, once we count all the links, we can print out how many that we counted. So we run this, and it says there were 498 href statements in our program. So that's pretty cool. We wrote a little program that did something that, was not exactly easy to do. Count the number of hrefs in there. And what's cool about it is that it won't crash. That's also pretty cool. So let's see. What else? So let me reiterate what your assignment is going to be. So now we've got in our, so my assignment again is Xcase is an XKCD downloader, right? Open up the webcomic XKCD and essentially what I want is your program to download the first 100 webcomics. In other words, the first 100 images that are on there. So I want you to download this, then this, then this, then this, all these images. Now they're all located at very different points, right? They're located in, so this one's located in images.xkcd.com, and they're in the comics folder under Veil Cropped. Can I look at the comics folder? No, I can't. Can't look at the comics folder. That's forbidden to people outside of his server, right? Can't look at it. I can only get linked to images in there. This one's located at Tree Cropped, right? So I can't exactly like iterate through the names and stuff, but I can iterate through the URLs, right? So I can go through comic 1, then I can go to comic 2, then I can go to comic 3. This is part of the reason I have you parse the first 100 comics of his webpage, because all you have to do is create a for loop and tack on what comic you're currently trying to download to the URL you're about to open. So it makes it very simple to iterate through them. So that's one part of it. The other part is how do I read this web page? Now this program that I'm describing isn't actually going to be too hard once you figure out how to put all the components of it together. So let's look at what a comic of XKCD looks like. And the reason why I like it is that basically all the things look very similar. All of his pages look very similar. So here's some stuff about, a link to the store, a link to his blog, which he calls a blag. You know, the sort of boxes, the title of the comic. There's a link to the comic right there, image source. And then if we read down further, it says permanent link for this comic. Go to http:// image URL for hot linking or embedding. And there it is. So there's a link to the image file that we want to download. So the question is, like, given a image file, and I'll use this on a different web page, right? Say we want to, famous Fantastic Mysteries, an American science fiction fantasy pulp magazine, right? Say we want to download this image. How do we do that? To be honest, I haven't the foggiest off the top of my head. I remember, though, that it's not exactly the hardest thing to do. But when you get like that, you're like, when you get to a thing like that, you go like, how to download a file, an image file using Java. And that'll bring you to Stack Overflow, of course, because why won't it? And it'll tell you a bunch of ways. And there's a number of ways to do it. Some people will say stuff like you open the stream, and this is the way I like to do that. Let's see how I did it on last semester. Right. So what I like to download a file is actually a file that's fairly easy to do. So let me go ahead and crawling new Java class, how to download image. Public static void main. Okay. So first thing you need to do is get the URL of what you want to download. Okay. And you need to connect to that image you want to download. And I said we wanted to download this thing, so I'm going to copy the link and paste it in. Now you have to find the URL of what you want to download, and if you're downloading the first 100 comics of XKCD, you're going to have to do that automatically. You're going to have to parse the web page to find that link. How do you do that? Well, I'll get into that, but essentially it's no more harder than looking for a line that starts with image URL and then grabbing the substring that starts it here. All stuff. This is This is basically putting together all the string manipulation stuff you've already learned how to do. All right. So remember, this part needs to be in a try catch block if it's not already. So let's go ahead and Alt Enter. Put this in a try catch. And then I'm going to go ahead and put everything else in a try catch block too. And I'm going to change the exception in the try catch block to, sorry, cut, paste. I'm going to change the exception in a try catch block to let's see, malform to exception E. Because I'm lazy. So it's essentially a 3-step process. Create your image URL, open a stream to it, and then use files.copy, where you copy from the stream, right? Stream is essentially a connection of data that you're grabbing. So grab that data from the web and copy it to some location on your hard drive. Now I'm going to be copying it into let's go ahead and copy it into the file mysteries.png. So I'll run it, and I should because I'm not going to get any output from this program, I should probably put some output to say that I want some output. Done. Okay, so run it. Done. Okay. So now I need to find out if I've actually got a file here. So F5, I don't need to copy it, but it's not showing up over here necessarily. And that's because your IDE can sometimes be a bit silly about these things and slow. So let me go look into the classroom. Oh, it does look like I downloaded something. I saw the image in my folder. So in intro, is it in intro? Is it in code? And is it in, let's find it. See, I was in last lectures. Is it in here? No, it's not in this folder. Not in this folder. It's not in intro. Is it in classrooms? I mean, you see that over there where we've got the fantastic. So let's go ahead and search here for mysteries. Okay, where are you located? Properties. It's located in /user/Andrew/classrooms. So this may just be my, oh, there it is. So it downloaded it to the top level directory of my project, right? My project's I keep all my code in Classroom, so it downloaded it to the Classroom web file. Now, one thing that you'll want to be aware of if you're testing your program multiple times is that if I run this again, it's going to yell at me. It gave me an error, even though it worked the first time. But if you read your error message, it's actually a very understandable error. It says java.nio.file already exists exception. Huh. There's no possible way I could ever interpret what that exception means. You know, that's a pretty obvious exception. It's saying that I can't overwrite the file already exists. It's not going to just automatically overwrite something that already exists on my hard drive, because that could be bad. Right, if I'm like overwriting my system32 folder, you know. So Java really doesn't want to overwrite your stuff without being explicit about it. So in that case, you either have to give it a new name. So maybe I think I could always call it mysteries1.png and download it again. I could also give it I could also call it a JPEG file, even though it's not. Here's the interesting thing: the file extension doesn't actually really matter. All it tells you is what file is like. It kind of really just tells you what program you want to open it with, right? It tells it that it doesn't really matter. So I could call it mysteries1 with no file exception, and it's perfectly happy to download it. It's just that when I go into here and go into Classroom, and now I've got mysteries1 over here, it says it's a file. It doesn't really know what type it is. I mean, without actually, you know, opening it up says it cannot be displayed because it is a binary file. Oh silly. Edit with Vim. And if I edit with Vim, it says Lead Technologies Incorporated v1. So it's not just a bunch of data, but I could read through this and probably figure out it's an image file. And thereby decide, oh, the thing I need to do is properties, so open with. Oh, wait, open with is at the top. So open with photo gallery. Oh, and it opened just fine without me having to specify the extension, right? The extension is an indicator of what program we should open it with. They're there for your convenience. Not necessarily, they're there for your convenience and for organizational sake. Which is why a lot of times that your program just hide, if you're using Windows, the default setting is to just hide the file extension, which is one of the things I turn off immediately. Anyway, so we've got an image. You don't want to download another one, but maybe I don't want it crowding around my top level directory. So what I could do is that I could put it into a folder like this, pics, and then I could put it into like a folder called pics, and then call it. So the way you put it in a folder is say your folder name and then slash and then your file name. Histories.png, and then I run it, and I should get another error because it will say that is a path that does not exist. And that's right, because again, it's wanting to be very cautious. It doesn't want to add anything to it doesn't want to add a folder that doesn't exist. It's being very cautious there. So if I create a pics folder now and run it, it will work, and it will put it in the pics folder. So, that way when you're downloading your XKCD comics, you can put them all into a folder, right? When you're testing it, and then you can delete all the stuff from that folder, right? Rather than crowding your web page, sorry, crowding your project. Okay, so I'm gonna delete all these. So a couple other things to note about files. This allows us to kind of go down in the directory, this slash notation, but it also allows us to go up. So dot slash just means here. Dot is here, this directory. Dot slash means put in this directory, mysteries.png. Okay? So put that here. And in file notation, dot dot means, anyone know? Sorry? Back a step. It means you go up. So this would mean in my parents' directory, put mysteries.png. So it had no problem with that. So let's go to my Andrew folder up here, and look, it's just placing that there. Which now should give you basically the idea for the most, and now you know actually how to make basically the most primitive piece of malware that you can make. Give somebody this program, have it execute, and it creates a bunch of files now on the computer's hard drive, each with a different name. It's pretty primitive, pretty easy to counteract, but that's these malware. Don't do that. You getting caught making malware will probably result in you being expelled or something. Not to mention criminal charges. Do not make malware. Only time you should ever actually consider making malware is part of a class when your instructor explicitly says, today we're going to learn how to write a computer worm or a computer virus, which is, what you have to do in order to understand how they work. Sorry? In this class? No. I mean, part of that is, so first off, Java is not necessarily the greatest thing for doing that. Second, C is pretty good at doing that because with C you can kind of modify the code that you're compiling, and also you can just do some really nasty tricks with C. Java has things to protect you from accidentally going out of bounds and stuff, and C really doesn't. And in C, you don't actually, the key is that I'm not accidentally going out of bounds. I'm intentionally going out of bounds. I'm intentionally messing with stuff that I shouldn't mess with. I mean, if you're interested, I can teach you some sorts of stuff there. But again, you shouldn't write malware, except as part of a kind of a class to do that. But I mean, again, a lot of malware is just basically creatively taking a legitimate program and saying, oh, if I ramp it up to 11, now it's a virus, or now it's a piece of malware. Now it's something that's malicious and harmful to people, right? Here I'm just downloading a file, right? If I'm downloading a couple billion files, right, that's bad. And if I'm doing it on somebody, and if I have this and get it on somebody's mobile phone and have them do that, now I'm hurting them personally because I'm racking up mobile charges. It really just depends on how nasty you think. And apparently I'm just not a nice guy. So I try to be, but apparently I've got a very nasty kind of mind. So, all right. So now we know how to download an image. We know how to and we know how to download an HTML file. Parse through an HTML file. Those are the two components you need to write this program. Again, what you're going to do is essentially you'll want an outer for loop, okay? And inside the for loop, you'll want a try-catch block, okay? So structured for loop, try-catch block, okay? And the for loop, what it does is that it iterates through and it says, okay, right now the URL I'm going to read is xkcd1. The next URL I'm going to read is xkcd2, and then 3, and then 4, and then 5. You got to do at least 100. If you can do all of them, fantastic. If you can, but 100, doing all 100 is what I'm looking for. Once you open up a connection to that particular comic, you got to parse through the page source. Now you can't just go and navigate to line to line 60 because it's not line 61 line 60 or line 61 because it's not going to be that for all comics. I don't think. Like 100, they have it on 61 as well, but it's not necessarily that line for every single comic. I know that because he sometimes changes it up. Okay, so be aware of that. You can't just hard code go to line 61. Instead, you got to parse through and go line by line, while there's a line to read. If that line contains this string that lets me know that it's a line with my image on it, then in this case, I need to take that line and get the part of the image I care about, which is get the URL to the image, which is what I care about. Now, a big thing that kind of hurt me when I ran this the second time is that the second time I wrote this program, I forgot to include the S in HTTPS. And that's not really kosher anymore. Notice that if I remove the S, and it immediately redirected me to HTTPS. Is that because I've got, I haven't enabled HTTPS anywhere. Well, my extension wasn't on, which would have forced that automatically, but it will. But a lot of websites will say, no, we're not communicating unsecured anymore. You got to communicate with me using HTTPS. So that's going to be the last program that I give out to you. So you've just got the Game of Life plus this program left. I don't really feel like getting too more ambitious with any new programs, so that's what you're going to have left. Now, let's go ahead but again, we're talking about in these last lectures, and I'm assuming basically that on Wednesday and on Monday, I'm going to use those times to go over to review. And to review, essentially, you're not getting a practice final this time around. I'm not writing you a practice final. Don't have the time to do that. Never have the time to do that. Instead, what we're going to do is that we're going to do what you do if you have a programming class and your professor doesn't provide practice finals, which is that you go and find finals or exams from other schools and see questions on topics you recognize and try to answer those. So that's what we're going to do. We're going to look at other finals. Yes. It's all year. It's all the stuff you've learned. I mean, and part of that's just because all the stuff we've learned is kind of cumulative, right? You can't, right? If we're working with arrays, you got to use for loops, and you're probably going to be using if statements And if you're checking for evens, that's going to use the module. Like, it all just goes together because it's all a bunch of skills that you had to master anyway. Now, as I mentioned at the beginning of class, for those of you who weren't here, it'll most likely have a large Scantron component. Like 60 points of it is like Scantron or something. A lot of it is code reading, right? A lot of it is focused on reading code, which is normally pretty brutal because it's easy to make mistakes when you're reading. So, you know, and then the rest of it is writing. So we do a lot of focus on reading there because it's because it's a common final. We've got like 200 exams that we have to grade together in one sitting. So being able to grade a lot of questions, you know, having like only 5 pages of code to go through, or 5 questions worth of code to go through manually and check ourselves, makes it a bit easier. Okay, so now let's go into a topic that I really wish we could go into more time in 1068, but we don't get too much of a time to go into do it for 1068, and this is part of the reason why we've moved, we're making 1051 a prereq for 1068, so we have more time for topics like this, which is recursion. All right, so who here has heard of recursion? A couple of you, right? But I'm going to assume that this is your first time hearing of it, and if you come to 2168, if you go into 2168 for any professor, they're probably going to have to assume that it's that in 2168 that's when you're first going to hear about recursion. So recursion is a very powerful programming tool, right? And it goes back to something that that was kind of really silly that we saw we could do during like one of the very first lectures. So new class recursion example. Okay. So we've got ourselves and what I showed is that I could have and this is I think from the very first lecture, I could have a method called public static void a, doesn't really do anything. And what it does is that I could have it print out, you know, foo, and then I could have it call itself. And then if I call it over here, essentially I get an infinite loop. Well, almost an infinite loop. I'll eventually get a stack overflow exception, which when you learn about stacks and the way recursion works in 1068 a bit better, it just simply means that that basically I dug too deep and my program ran out of basically space to store method calls, and so it crashed. But the idea here is that there's nothing preventing me from having a method that calls itself, right? And that just seems like it's silly that you can blow your own foot off. But it's actually a very useful technique for programming. It allows you to write very similar stuff. How many of you have learned about mathematical induction? One or two of you, if you've taken the higher level math courses, which simply says that basically that you've got, and if you've had to do proofs in math, basically proof by induction basically seemed like the easiest of the proofs, which is that basically you prove that the equation that you've been given, it's true when x is equal to 1 or n is equal to 1, and then you prove that it's true for n plus 1, right? If it's true for n, it's true for n plus 1. It seems like it's really easy. It's kind of a bootstrapping method to do it. And showing that recursion works is pretty similar to that. Again, more details in 2168. But what we can do with recursion is let's talk about like a classic mathematical equation. Public static void. Let's go ahead and actually do this. We're going to return a long for once rather than an integer. Factorial of int n. So passed in an int n, we're going to return some factorial. Right now I'm going to return 1. Okay. Now factorial, right, if for those of you, just to remind you, those of you in the know, it looks like this. N factorial. In other words, n, and then it's got the exclamation point after it. Okay? Now, how many of you have never seen this symbol before? It's okay if you haven't. Okay? Either nobody wants to admit that they've never seen it before, or we've actually done a proper job in our math education, which is fantastic. So for a reminder, what n factorial is, it is n times n minus 1 times n minus 2, you know, and so on and so forth until you get 3 times 2 times 1. I don't think there's really any kind of negative factorial, but we do know that we have the caveat that 0 factorial is equal to 1, right? And that, for example, and to give ourselves an actual example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is actually, so that's 2, 6, 24, and then that becomes 120. So it is, so now the reason I'm going to be returning along is that factorials get really big really, really quickly. Okay? So let's go ahead and write a program. So it makes pretty good sense. We could reverse this obviously because it's all commutative. So we can do, instead of 1 times 2 times 3 times 5 times 4 times 3 times 2 times 1, we can do 1 times 2 times 3 times 4 times 5, right? So we can do that in a for loop. So int product is equal to 1. When we do a running sum, right, we start with 0 because 0 is the essentially identity function for addition. You can add something to 0 and it gives you the number you added. For multiplying, you want to multiply by 1 because if you're multiplying by 0, you're going to get 0. If you multiply by 1, you get the number you just multiplied by. So that's why you start with 1 as the product. And then we're going to return our product. Okay. So let's go ahead and do, let's see. So for int I is equal to 0, not 0, I is equal to 1, I is less than or equal to n, I plus plus, product time equals I. Return product. So product, not product, but out factorial of 5. That will return 120. Factorial of 10 will return, hold on a second. Oh, it just didn't register. 362, sorry, that is 3,628,000. So these numbers grow very quickly. If I bring this up to 20, it brings up a negative number. Oh, because I was storing an int in for product, right? And it was bigger than 2 billion, so it wrapped around. So I need long to hold that number. It got really big really, really quickly. In fact, it's going to outgrow the space that you need for a long without much trying. All right, but that's a problem for another day. So factorial is that's just the nature of factorials. Okay. Now otherwise, what do we need to know about? So this is a way to compute these things, right? But there's a completely different way of thinking about factorial functions, right? Or about the factorial operation, which is to kind of define it in terms of itself. Okay, let me just quash this error with return -1 right over here, and give it a new name. Okay, you can quash that. So now I mentioned that 5 factorial, right? That's equal to 5 times 4 times 3 times 2 times 1, right? But we can actually do something interesting here. We can look at this and we can go, well, it's 5 times 4 times 3 times 2 times 1. And multiplying all this stuff together, I am a very lazy person by nature. So if I look at that, I may be lazy, but I'm smart. If I look at that, I'm like, wait a second. That's 5 times 4 times 3 times 2 times 1. 4 times 3 times 2 times 1, that's what? What is that? That's 4 factorial. Somebody understands this concept. So 5 factorial, we can redefine that as 5 times 4 factorial. Now 4 factorial, that's 4 times 3 times 2 times 1, but we can redefine that as 4 times 3 factorial. That makes sense to everybody? It's 4 times 3 times 2 times 1. Again, that seems like a lot of work to work through. 3 factorial, on the other hand, that's 3 times 2 times 1, but I'm really lazy. 2 factorial is a lot of hard work. Doing that's a lot of hard work too. 2 factorial is equal to 2 factorial is equal to 2 times 1 factorial, and 1 factorial is equal to 1 times 0 factorial. And we're going to just stop here because we know that 0 factorial is equal to what? 0 factorial is equal to 1. 0 factorial is what we call a base case. Essentially, the bit of information that we know that's so simple that we don't actually have to do any computation to solve it. So the way recursion works is that it's essentially redefining this entire equation as, well, n factorial is equal to, well, it's going to be equal to one of two things. We're either going to say it's equal to n minus 1 factorial, sorry, n times n minus 1 factorial, if n is greater than 0, right? If it's greater than 0, then the equation is n times n minus 1 factorial. But it's 1 if n equals 0, right? If n is equal to 0, then, if we get 0 factorial, then the answer we return is 1. So this leads to something that will look like it shouldn't work at all. But it does. It looks like it shouldn't work, but it does. It leads to what we call a recursive function, a recursive definition, something that refers to itself and calls itself. So if n is equal to 0, we return 1, right? We said 0 factorial. If you give me 0 factorial, I'm going to give you 1 back. Otherwise, I am going to return well, I know that if it's n factorial, if I'm calculating n factorial, then I'll do n times, that's equal to n times n minus 1 factorial. And that is a recursive function. So let's run it and confirm that this piece of magic works. And it does. So the question is how? Well, all recursive functions have 2 portions to them. And depending on what the problem is, they can both be easy, or either of them could be hard, or maybe one can be harder than another, right? But in most of the cases we're going to look in, they're both very easy things to do. The first is to figure out the base case, the piece of information that's kind of just given to you. It's like that. It's like proving that initial step in the inductive case. For factorial, it's saying, well, if everything, if we're given 0 as the factorial, then we know that if we're trying to compute 0 factorial, we know that's 1. If, on the other hand, we are given, n, some number that's not 0, well, then we return n times n minus 1 factorial. Now, this second case, this else, is what we call the recursive case. And notice that it's got a little symbol on my IDE indicating that it's a recursive call, just reminding me there that it's a recursive call. Now, the key for recursive calls is that they do not go on forever. Recursive calls must make, in order for it to be a recursive function, it needs to not go on forever. It has to make its way to the base case, right? We're going to stop at the base case. The base case isn't going to call anything else, right? So if we pass in 5, is going to do 5 times factorial 4, which is going to call this pass in 4, which is going to call 4 times 3, and then call in 4 times 3, and then that's going to call 3, pass it into here, 3 times 2, which is going to call 2, which is going to pass in 2 to here, call 1 times 0, and then we're going to get 0, which is going to return 1. Then we're going to do 1 times 1, which will return 1 to the 2 call. Right? So this is actually much easier to kind of draw on the board over there. Or once. Oops. Of course it's dry. 5 factorial, right? We define 5 factorial as basically 5 times 4 factorial. And we look at 4 factorial. 4 factorial is, so 5 basically says 5 times 4 factorial. 4 factorial is 4 times 3 factorial, which is 3 times 2 factorial, which is 2 times 1 factorial, right? So 5 calls, 5 times 1 factorial. Let me actually do this properly here. So 5 times 4 factorial, 5 factorial calls 5 times 4 factorial, which calls 4 and 4 factorial calls 4 times 3. 3 times 2 factorial, 2 times 1 factorial, and then 1 times 0 factorial, right? So we don't actually solve anything until we get to the bottom. It just simply says 5 times, I'm going to multiply times 5 times whatever the answer of 4 factorial is. 4 factorial is going to be whatever the answer of 4 times 3 factorial is. 3 is going to be, and that's going to be whatever 3 times 2 factorial is, and that's going to be whatever 2 times 1 factorial is, and that's going to be whatever 1 times 0 factorial is. And now 0 factorial, we know, is what? Let me go ahead and actually just move that out of the way so that you can see it better. So this is 1. So we now know that 1 factorial is going to be the result of 1 times 1. So that's 1 over here. So 2 factorial is the result of 2 times 1, which we plus 2. 3 factorial, so we then do 2 times 3, 3 times 2, which returns 6 as the answer for 3 factorial. Then we do 4 times 6, which returns 24 as the answer of 4 factorial. And then we do 5 times 24, which returns 120 as the answer of 5 factorial. So essentially, we dig our way all the way to the bottom, and then we pass our answers back up. So it's kind of a weird, I'm not going to ask if it makes sense to everybody, because it's not going to make sense to everybody on your first go. It's kind of a bit of a thing to get your head around. It's a completely different way of looking at things, a completely different approach. Recursion is a very elegant solution to Java. And actually, once you understand it, and it's pretty much if you're going to get a computer science degree, you got to understand how to read these things at the very least. I expect you to understand them, and to be able to write them. But you got to also know how to read them. And once you understand how to read them, it's much easier to read a recursive function than it is to read an iterative function. A lot of times, recursive functions aren't necessarily as efficient as, like, doing stuff with loops. In fact, a lot of times they're less efficient than loops. But what it's made up for is the ease of which you can read them and the ease of which you can write them, which means less code to read, less code to debug, which makes it a bit easier sometimes. So that's our factorial function. Let's see. Questions on recursion so far? Let's see. All right. So what we're going to build up to on Monday is a common problem that we do in searching. Sorry, with arrays, which is called searching. Okay, so let's consider the problem of searching for a second in our last 10 minutes of class. So this seems like a bit of a out of left field for with going on recursion, but the most efficient way to do this is to use recursion for some cases. Okay, if I've got an array, so let's take a look at this array. Public int. Now I'm just going to write array here over here. Let's go with our array. Int array is equal to 7324668. Right? Now the searching problem, basically searching is essentially the question of asking, hey, where is 1 in this array? Or where is 5 in this array? So for the answer for 5, where is 5 in this array, we'd say, oh, 5 is at index 0, 1, 2, 3. It's at index 3, right? If we're looking for 1 in this array, we'll say that 1 is at index -1. Why -1? Any suggestion as to why? Why -1 if it's not present in the array? Because, sorry? Yeah, it's not a valid space. So we're saying, yeah, you can find it, you can find it basically in a place that doesn't exist, right? You get negative, and -1 is basically the way to indicate that in Java. We tell them that basically in Java, the way of saying that basically that it doesn't exist in this array or at this index is to say -1. Why? That's just what they determined for the programming language. That's the behavior they want. And because if you try to search for it, it will give you an out-of-bounds exception at -1. Now, that's not necessarily good for all programming languages. This is one of those cases where basically the way you learn something will actually backfire in a different programming language. For instance, Python. If we look at Python, if I create a list of items, which is kind of like an array, right? And if I say, so index of 3, right, it's going to say 5, index 4 is 7, index, if I say index 5, that's going to give me out of bounds. But if I say, for example, -1, it's going to give me 7. It's going to give me the last item in the array. And -2 is going to give me the second to last, and -3 is going to give me the third to last, because that's the way Python interprets negative values there. So just be aware of that can happen in different languages. So the searching problem basically says, I want to search an array for this thing. Now, if I want to in most arrays, they're not sorted. So in order to search for an item, you have to go through the entire list to find it. The problem we're going to be focusing on Monday is sorted arrays actually can be, we can ask what index something is at. So here's a sorted array, right? And I want to find, now I could do it the same exact way. I could just look left to right for the item. Like, what index is 9 at? And I could go, well, 0, 1, 2, 3, 4, 5. It's at index 6. 9 is at index 6, right? But there's another way and a faster way to do it. And that's what we'll return to on Monday. That's what we'll basically do as our last topic, I feel, on Monday. And then on Wednesday, we'll do a review session. And on Friday, and then on the final Monday of class, I'll do some more review. And congrats to making it to the end of the course. So, All right. So see you guys on next Monday.